Hello and welcome students. The physics section, the first lesson, physical world. Before entering the physical world, let us move on to the basics of physics. First of all, what is physics? All of you know that physics basically deals with the two entities of nature. One is matter, other one is energy. Do you know what is matter? That is anything that occupies space and has a mass is called matter. And how matter manifests itself? Matter manifests as solids where atoms are closely bonded. Next is liquids, and the last one is gases. Okay. So physics basically deals with two things, that is matter and energy. And what matter composed of solids, liquids and gases. And one more thing, what is energy? All of you know that it is the capacity to do work. Always work is done with the expenditure of what? Energy. And we say energy is a conservative. Do you know the meaning of conservative? The basic conservation laws says that what is the conservation of energy? It says one form of energy can be converted into another. And however, you have learned the fact that energy is neither be created nor be destroyed. But what could be done? One form of energy can be converted into another. The best example for the conservation of energy, that is light energy can be converted into what? Electrical energy, where in a solar source. So there are many forms of energy. We say light is a form of energy, heat is a form of energy, electricity is a form of energy. How come electricity is a form of energy? Because you can transform electricity into other forms now. So whenever one form of energy is transferable to any other, then we say in the nature what is conserved, energy is conserved. And it was Einstein who gave a relation between mass and energy. What is the relation between the mass and energy? E is equal to what? mc square. According to Einstein, mass is converted into energy. The best example for this is an atom bomb. Energy can be converted into mass. Do you know the example for conversion of energy into mass? Very rare examples you will find in the universe. One example to illustrate conversion of energy into mass is pair production. That is, when a gamma rays undergoes decay, it is known to emit two particles. As you know, gamma ray is a radiation, means energy. It is known to emit two particles called an electron and a positron. So this is a very good example to illustrate an idea that energy transforming into matter. So Einstein said that mass can be converted into energy, energy can be converted into mass. And we move on to the more important aspect of physics is the physical quantity. Actually physics, I said it is a study of matter and energy. Moreover, physics is a measurement science. So, in that way, we have physical quantities. Do you know what are physical quantities? Any measurable quantities are called physical quantities. Any measurable quantities. Any measurable quantities are called physical quantities. Any quantities, if you are able to measure them, they come under physical quantities. For example, can you measure the happiness? Can you measure the sorrow? So these cannot be physical quantity because you cannot measure them. So any quantities which are measurable, one, are called the physical quantities. When we talk of measuring the physical quantity, generally we need two important terms. One is a number, other one is a unit. How the number and units are related? Number and units are inversely related. What does it mean? If a physical quantity has a smaller unit, the number will be large, numerical value will be large. Smaller is the unit, larger is the numerical. Larger is the unit, smaller is the numerical. Always for measuring any quantity, we take n into u as constant, or n1 u1 is equal to what? N to u2. For example, 1 kg is equal to how many grams please? 1000 gram. What does it mean? Gram being the smaller unit, that's why see the numerical value large. Kg being the larger unit, that's why see the numerical value small. Is it not this point is illustrated? So to measure any physical quantity, what you need is a number and a unit. Now what does a number signify? Of course, the magnitude of that physical quantity. Now what unit is signified? Unit will help you to identify the physical quantity. When I say second, is it not for you to identify the quantity involved over here? That is time. When I say gram or a kg, is it not this unit made you to think of the quantity involved? So that is why to understand or to identify the quantity, we prefer unit for it, and a number to specify the amount or magnitude. So therefore, how the number and the units are related, I said, for any measuring physical quantity, they are inversely related. So can I give one more example, please? For example, 1 meter is equal to how many centimeters? 100 centimeter. Just see, is it not the same idea is being illustrated here? That is, centimeter being smaller, number is large. Meter is large, number is small. So let us revamp the basics one more time. What are the physical quantities? The quantities which are measurable one are called physical quantities. And how do you measure physical quantities? By number and unit. How do you relate that number of a physical quantity is inversely to what its unit chosen. Therefore, nu is equal to constant. See, in the physics, we have many terminologies. Among those terminologies, we come across a term called particle. Now, when we say an object as a particle, there is some simple guidelines where we have to consider object as a particle. See, the distance travelled by the object, is very large compared to its dimension. Can you follow the idea? The distance travelled by the object is very large compared to its dimensions. Under these circumstances, we take object as what? Particle. In the sense, we neglect the dimensions of a particle. One example for this is, if a bus say moves from Gulbarga to Patna, or now we say Kalburgi to Patna. Okay, all of you know that a bus has its own dimensions. When a bus moves from Kalburgi to Bangalore, how you analyze the movement of the bus? As a particle, because the distance covered by the bus between Kalburgi to Bangalore is very large when compared to dimensions of the bus itself. So this is the concept used to treat the object as a particle. Even while measuring the distance between, say, Earth and the Sun, okay, we take Earth and Sun as a particle. Why? Because the distance between the Sun and Earth is very large when compared to dimensions of Earth and Sun. Did you follow the idea? So when we take an object as a particle, so over here we took Earth and Sun as a particle because the distance between them is very large when compared to radius of Earth and Sun. So this is what the term particle. Now for field of mechanics or for field of thermodynamics, for any area, we go for some concepts. So generally physics talks about concepts only. Now let us understand what is a concept. Concept means an idea. It is an idea, nothing else. An idea used to define. This we have to practice it for 1 month also. Okay? An idea used to define any natural phenomena. Okay? What is a concept? Or what are the concepts? What is the concept we will say? What is concept? An idea used to define any natural phenomena. For example, when you are asked to analyze the motion of an object or motion of a particle, how do you analyze the motion of a particle? Motion of a particle. When a particle say has moved from point A to point B, how do you analyze? First thing is the particle has moved from A to B means we say particle has a cover distance. When we assign a direction for it, we say particle has a cover displacement. When the time aspect is involved, we go for speed, and that is the distance by time. With the direction analysis we are doing, we go for velocity. When velocity changes are being produced, we go for acceleration. Just see, only event called the motion was explained by these concepts we use. Just see, a motion of an object can be analyzed with these terminologies. We group them as concepts of physics. In order to define motion of a body, we use the concepts like the distance, the displacement, the speed, the velocity, acceleration, and force, and work done. Okay, then the last one is power. So these are the sequence we follow in analyzing the motion of an object. So how we analyze the motion of an object? By using all these concepts. Please remember, force is a concept, work is a concept. What for? Only to explain the event point motion. Similarly, in thermodynamics, we use a concept called temperature. What does the term temperature stands for? This the degree of hotness or coldness of a body. Just see how these terms are used just to explain some phenomena. Okay, so the concept is an idea used to define any natural phenomena. Now, how the scientist analyzes any natural phenomena? We say they do follow what are known as scientific methods. In order to analyze any process, they do follow what are known as scientific methods. Sometimes we say think scientifically. Actually, what does it mean? What are the actual steps involved in a process called as scientific methods? How actually scientists analyzes any given or any natural phenomena? So first step is what they say: careful and systematic observation. First they go for careful and systematic observation. After observation, they do collect some information, and that is called the logical reasoning. After the careful and systematic observations, second step they do follow is the logical reasoning. Logical reasoning. Third, after information on their own way, and this is what process we call as a logical reasoning. After logical reasoning, they go for formulation of a theory. Formulation of a theory for the phenomena they studied. Formulation of a theory. Next, testing the theory. Okay, testing the theory. How do they test it? With the experimentation and observation. If the theory was found to be true after observation and experimentation, they transform it as a law. If it is not found true, they again have to follow the above sequences to analyze simultaneously natural phenomena. This is the general methods the scientists follow to analyze any phenomena. Okay, so what are the steps involved in a scientific method? Just let me list out. One is called careful and systematic observation. Second one is logical reasoning. Third one is the formulation of the theory. Fourth one is the testing the theory with experimentation and observation. And one more term that you need to know is for all these sometimes they go for a model also. What is a model? It is just a physical representation of a system. Let me repeat. What is a model? Sometimes the scientists make a model. What does a model stands for? It is just a physical representation of a system. For example, light is a system. How do we represent the light is? Light is modeled as a rays. This is another way of representing a system physically. That is model concept. Okay. So let us revamp what you have learned in this session. First thing I said that physics talks about matter and energy. And matter, anything that occupies space and has mass. And matter manifests in the world as a solid, liquid and gas. Energy, a capacity to do work, and energy in the nature is conserved. That is neither be created or destroyed, but what it allows to transform one form to another. That is the beauty of the nature. All energies are transformed from one to another. In fact, the one which is transformed from one to another is generally called as an energy. And after that, we have seen physics basically talks about the measurement and the quantities which are measurable one we refer as physical quantities. And how do you measure a quantity is with the number and the unit. How the number and units are related? Inversely. Then we had some terms like three important terms you have seen in this session. One is particle. Okay. Second one is concept. Third one is model. Can you revamp to that? Particle means when the object was considered as a particle means the distance travelled by the object is very large compared to dimensions of the object. Then we take that object as particle. What are the concepts and ideas used to define any natural phenomenon? Then what is a model? It is just a physical representation of a system. Can you give an example for a model? Light is modeled as a rays. Okay. Conservation laws. First of all, what are the conserved quantities? What are conserved quantities? Conserved quantity means these are the quantities which do not change in any process. These are the quantities which do not change in a process. Conserved quantities means that these are the quantities which do not change in a process. The examples are energy. And another one is a charge is an example. Next one is a moment. So in any process, if the quantity remains same, that we call as a conserved quantity. Accordingly, we have conservation laws. Just now I said conserved quantities are energy is a conserved quantity because it remains same in a process. Charge is a conserved quantity. Momentum is a conserved quantity. Accordingly, we have conservation laws. So what are conservation laws? One is a conservation of energy. Conservation of energy. So what does it mean? Conservation of energy means that it is neither be created nor be destroyed. But what is allowed? Transformation of one form of energy to another. For example, in a thermal plant, what is happening? The heat energy is converted into electricity. And you know, in Karnataka, Raichur is the place where thermal energy is converted into what? Electrical energy. And in a solar cells, what is happening? How the energy is conserved in a solar cell? That is by transforming the light energy into what? Electrical energy. There are many examples that illustrate what? Conservation of energy. So, conservation, our earlier definition was neither be created nor be destroyed, but one form of energy can be converted into what? Another. And all of you know that energy has many forms. Just now I have listed out light energy, heat energy, recently nuclear energy, atomic energy, many more. Okay, wind energy. So these are conserved in the nature. Second one is conservation of the charge. Conservation of charge. So, what is the conservation of charge? Once again the same thing. Charges are neither be created nor be destroyed. But what is possible? Electrons can be transferred from one body to another. For example, when a glass rod is rubbed against a cell, I think you might have studied electrostatics in earlier sessions. When a glass rod is rubbed against a cell, here glass rod loses electrons, so it acquires a positive charge. Silk gains electrons so that it acquires a negative. But actually nobody has lost, nobody has gained. What actually had happened? The glass rod transferred its electrons to silk. That what illustrates the conservation of charge. Just take examples of nuclear reactions. In all the nuclear reactions, even in the radioactivity, what is being conserved? Charge. The conservation of charge, the best example is all the nuclear reactions. How many nuclear reactions we have? One is a fission, other one is a fusion. In that, the charge is conserved. Means simply electrons are transferred from one body to another. Next one is a conservation of momentum. Okay. Conservation of momentum. What is the momentum? We actually have two momentum. One is a linear momentum, other one is angular momentum. Linear momentum is a P, which is this one. Angular momentum is L, which is I omega. So what is conserved? They say momentum is conserved. What is the momentum conserved is? If at all any change in momentum is produced, for example, when a bullet is fired from a gun, what actually happens? The bullet moves forward, the gun recoils to conserve what? Momentum. So, angular momentum, all a rotating body will try to conserve what? Angular momentum. So, therefore, conservation of momentum means any change, if at all we produce, they sustain, they try to counter the change. Just like I gave an example, a bullet fire, initially the bullet and gun have zero momentum. With firing also, they do have a zero momentum. Means once again the momentum is conserved. This is what we call as a conservation of the momentum. And one more is the conservation of the mass energy. Actually, we have a mass conservation as well as energy conservation. But now the scientists are saying the mass energy conservation. What does it mean? Mass energy conservation means here also they are focusing on the transforming aspect. Mass energy conservation in the sense mass is converted into energy and vice versa is also possible. That is energy transforming into mass. Just now already we had discussed about Einstein's equation. That is E is equal to mc square. It is a theoretical equation. Actually, this is the equation he had in his tree. E is equal to mc square. Okay. So mass energy conservation in the sense mass transforming into energy and the energy is transforming into mass. Already we had seen examples for mass converted into energy, that is nuclear reactions, nuclear fusion, whereas energy converted into mass is the decay of gamma ray. When the gamma ray decays, it is known to give two particles, that is electrons and positron. Okay. So now the physics has a very interesting aspects to deal with. Now earlier we used to take the atom has that is atom has an electron inside the nucleus, proton, neutron. But do you know the present scenario? Today we are able to identify almost 36 fundamental particles within the atom. Earlier we used to say atom is the smallest particle, but today within the atom we could able to find almost 36 fundamental particles. That is the beauty of physics. Okay.